Thanks, Ruby. So on the 12th of August, the ACT went into lockdown. As I'm sure you can imagine, this posed a major problem for the team. I mean, sure, it halted all the work the technical team could do and threw everything we'd worked towards into the air. But more than that, I missed my friends. That's one thing that I think doesn't get talked about enough when we talk about the team, and that I think is obvious in just about any picture that is taken of more than just a few of us. We're all friends, and the jokes and time we spend together, I think, are just as important as the car. But in saying that, I'm not a member of the technical team, and I'm sure if I spent as much time working on the car as they do, I might have a different opinion on that. Anyway, after the beginning of lockdown, I sat down and thought, what can I contribute to bring everyone together with us all having to be apart physically? I figured I'm pretty good at talking colloquially in front of a bunch of people that I should probably be formally presenting to, like I'm doing right now. And I know a bunch of facts that are only useful in their uselessness. So I thought, can't really do much but with that. And then a couple of days later, I figured out that those were exactly the skills necessary to put on a trivia night for the team. However, it wasn't a super straightforward process from idea to event. What I really wanted to do for the team at Trivia was to try and create the same kind of environment that one has at a trivia night in a bar. I wanted to try and make the team feel like they weren't in the rooms they had been locked down in. I also wanted to give people a place where they could talk to the other people on the team, maybe even team members they didn't know very well, and sort of reveal things they knew. Reveal things they knew about stuff that wasn't just engineering or business. It was immediately pretty clear that the bog standard Zoom call was not going to cut the mustard. So I went about solving the problem of how to break everyone up into rooms so that they could talk amongst themselves without giving away their answers to the other teams. Next slide, please. Sorry, next slide, please. Thank you. In the end, the solution I settled on was to run a live stream on YouTube, which is what you can see here. Provide a link to everyone doing trivia and separate them into breakout rooms. This way, I could talk to everyone directly, make jokes, and even play a bit of accompanying music with a slight delay. Next slide, please. Next, I had to draft up some questions, and I've got a couple of my favorite questions up on the screen now. I picked these questions because I think they demonstrate the kinds of questions I wanted to make. Questions you might not know the answer to, but that you can guess at pretty well. I also love throwing in multiple answer questions because nobody gets none of them right. But if you ever get all of them, it's a great feeling. These kinds of questions ensure that even if you aren't particularly proud of your trivia ability, you'll get a couple over the course of the night. By the way, here are the answers to those questions. Next slide, please. Awesome. To sum up, and I think, or at least I hope, others enjoy it too. Sorry. To sum up, I really enjoy it, and I think, or at least I hope, others enjoy it too. Although I do throw the occasional question in to really quiz people on things they should know, to make sure everybody's been paying attention in their meetings, which the exec just loves. I think the best thing about being able to do trivia in lockdown, though, is that it forced me to learn new skills. Without being able to simply outsource it to other people who know how to run a trivia night, I was forced to learn a new skill set. A skill set that I really can't wait to bring to our in-person events. I don't know if trivia would have its place amongst reveal events, but it's something I have in my repertoire that I could bring to recruitment drives or team get-togethers. I'm really looking forward to being able to put something like that on, thanks to the support I get from the team. Now I would like to introduce Jasper, who is going to talk about the process of adding the tail lights to the car.
Hey everyone, welcome. I'm here to talk to you about a bit of an enlightening journey and how myself and Ryan designed and manufactured custom lights for our car. Next slide, please. So custom lights for the car. So you might be wondering, why are we actually building our own lights when there's plenty out there? Well, the answer to that is the mechanical team absolutely loves their aerodynamics. And as much as I've tried to fight against them, aerodynamics typically wins out. So in the pursuit of these superior aerodynamics, we got left with just about zero room for our indicators, in particular up the back. So in that bottom right image, you might just be able to see it's barely noticeable, but there's a small little orange smidge where the rear indicators are supposed to go. That space there is only about 1 centimetre tall and 15 centimetres wide. Now 15 centimetres wide is plenty of room, but 1 centimetre, that's nothing. Retail indicators, by comparison, typically about 4 to 6 centimetres tall. And in this little journey of manufacturing these lights, we discovered there's a lot more to this than meets the eye. As with all engineering problems, once you start breaking something down, looking at the standards and regulations, there's a lot of work that goes into just about every system in everything around us. Next slide, please. So the initial design. So the initial design for the car, in keeping with the space we had available, was absolutely tiny. So in that image with a whole bunch of PCBs, you'll be able to see 2 different PCBs. We have 2 long ones and 2 kind of squarish ones. So the long ones are the backlights, which include indicators and brake lights, and then the small ones are the front indicators. So the individual LEDs on these indicators are absolutely tiny. You can see in the top right, they're about the size of a grain. This is something Ryan, who manufactured the lights, absolutely loved, and he'll go into that a bit more. These LEDs themselves were super bright, which is why we didn't really need many of them, and they ended up being absolutely tiny overall. So we coordinated this design, I didn't mention, is actually online. So I myself am currently down in Adelaide. I moved here earlier this year for work, and I was supposed to be back in Canberra more often, but lockdowns, restrictions, everyone knows, makes it a bit more difficult. So this is just a kind of example of how we coordinate online and work well together. So I'll pass over to Ryan now to go over the manufacturing.
Thanks, Jasper. And so I was responsible for manufacturing the brake lights and indicators for the car. Because of how small the LEDs were, I needed a microscope and an oven to properly manufacture the lights. Thanks to the Research School of Earth Science for lending us the tools and equipment to make the lights. Manufacture went without a hitch, but the testing highlighted some major flaws. Next slide, please. And yes, the lights almost went up in flames. The lights that we picked were incredibly bright, even brighter than my future, but LEDs are not 100% efficient. They also generate heat. The green PCBs behind the lights, they are typically made of fiberglass, and glass is a heat insulator. So all the heat that the LEDs generated had nowhere to go. So the LEDs got hotter and hotter till the solder melt or either burnt off. And also the amber LEDs were kind of red. Back to you, Jasper.
Cheers, Ryan. Yes, as you can see, there's a few problems with the first design. And this is something that didn't become apparent until a bit later down the line because of the difficulties of coordinating online. So every time I came up with a design or something, I'd have to send it over to Canberra, and then we'd have to actually set up online meetings, explain things, get things shipped. It really slows down the design iteration process, especially with lockdowns and other interruptions, and shipping being especially slow. So once we finally realized that the first design wasn't quite working out properly, due to the naive assumption that air cooling would be sufficient, we moved on to the second design. So we figured the only way from the previous design is up. And what's better than having only a couple LEDs? It's having about 5 times as many, which is why I decided to use 27 lights per indicator, or brake lights, sorry, they're combined. So one thing you'll notice here is we've kind of dropped the front indicators because when the chassis arrived, we realized we could actually fit an off-the-shelf indicator in there, which was music to my ears because the design specifications for that are much tighter. So this design, whilst using about 5 times more LEDs, actually generates a lot less heat because instead of going for the super duper bright individual LEDs, we went for dimmer LEDs over, individually, but which use about 1/5 as much power. So the PCB itself is also made out of metal, which sounds a bit kind of funny, when you're talking about electricity. But using a couple of special techniques, you can make them out of metal, and they actually dissipate heat really, really well. They also separated out the power supply from the actual indicators. So you didn't see that on the green ones because it was on the rear side, but the power supply was on there and that generates heat itself. So by separating that out, generate less heat overall. Next slide, please. So as already mentioned, the design of lights was completed across borders. So I think probably my favorite moment from this was when the design finally arrived in Canberra. And then Ryan, Rory, and a couple of other electrical members started messaging me saying, what's up? These LEDs are tiny. How am I supposed to do this? At which point I replied, oh, I can't help you. I'm in Adelaide. But no, coordinating, we figured it out and they got it manufactured all nicely. But lessons learned from this is the systems in our car, which seem simple and small, actually often have a lot more that go into them. We have to do a lot of research and development, and everyone on the team works really hard. So in designing, iterating online is a challenge, which is only made possible by our teamwork. And more importantly, we don't always get the design right on first try. We are students, we're here to learn, and we're here to build the best car we possibly can. And we're sure as hell not going to give up until we get that car on the road and it's operating in peak form. Next slide. Anyway, I hope you've been enlightened and have a good Arvo.